Okay, hello everyone. I want to make this very short. I neglected in class live on Friday when talking about isomorphisms to say anything about an actual tool that you might use to help yourself see that two graphs are isomorphic, because though it's a discrete notion whether two graphs are isomorphic, whether or not there exists this isomorphism, which is this function which maps vertices to other vertices, in practice, you're going to just do it visually. And so, how can you do this? Well, Gossett himself even mentions, in some kind of way, hey, you might want to use some thing like Sandbox or something like that, which is just some, probably, I assume, crappy piece of software from 15 years ago or whatever. Okay, these textbooks are always very out of date, so I am going to teach you how to do this with Geogebra. So, please, okay, what is Geogebra? It's a extremely powerful and interesting software package, which is free, it's online, it's web-based, and it does a million things, including every single thing that sort of a graphing calculator can do, kind of like plus more. Also has a lot of geometric functions that kind of are making old things like Sketchpad obsolete. And okay, here we go. Please go to geogebra.org, and then you're on this screen. All right. Also, I should say that it's not meant for this. So this is not actually the best program out there. I'm sure there are others, but this one is like free, simple. I'm already an expert on it, so whatever. But it's not really designed for this. Anyway, okay. So what am I doing? Go to geometry, and here you are now. In okay. Nah, I think I can just. Okay. So here we go. This is a completely blank screen. Over here on the left is your set of basic tools. Okay, this is going to be kind of hopeless for me to teach you everything you need to know about GeoGebra. So I'm not going to try. Those of you who took advanced geometry with me in the fall, we spent like hundreds of hours of our life with GeoGebra. Actually, it does have a lot of quirks. If you click on more, you get sort of the full range. Actually, not even. You get some of the things, and if you click on more again, you get really like all of them. So what can you do with this? You can, construct lines. You can construct parallel lines. You can bisect angles. You can construct tangents. You can use sort of every possible Euclidean construction plus many other non-Euclidean constructions. It's very, very powerful. But we're not going to do any of that stuff. What we're going to do is just click on point, and we're going to make some points. Okay, so specifically, I'm going to do, I see now that I did not actually bring up a picture. Never mind. Who cares? I'm going to page, let's see, can I write this somewhere? Yeah, here's what we'll do. We're going to go to our textbook, page 623, which is section 10.4 and 10.4. And I was going to go to do one of these problems, specifically problem number 10C. This is not one of the ones I assigned, but I assigned several problems that are exactly like this. And okay, and honestly, without something like this, I don't know how you would possibly do this homework without something like this. At least I wouldn't be able to. So let's go. What happens in this number 10C? They give you two graphs, or rather, they give you two pictures of two graphs. And the graphs are simple, and they ask, hey, are these two graphs isomorphic or not? In fact, the exact directions say, produce an isomorphism for the pair of graphs, or explain why the two graphs are not isomorphic. A click and drag tool such as Sandbox will greatly simplify the task. Okay, so we're not going to use Sandbox, whatever that is. We're going to use GeoGebra, although feel free to use something else. And there are apps on your phone and stuff too that are kind of good, some of them, but some of them are not so good. So anyway, without further ado, we go. I'm going to make this graph. Okay, you don't have it in front of you, but just watch me. It looks like this. There's this point A, B, then there's this point over here, C, D. Note that GeoGebra will automatically, by default, when you construct a new point, will label it, and it will go in alphabetical order. So you can use that to your advantage. So like E, F. And now I'm going to do something super smooth that a kid taught me once, which is, that's one graph. I haven't drawn the edges yet. The second graph uses vertices U, V, W, X, Y, and Z. So I want U to be my next point. So I'm just going to burn through some points, So I'm just going to burn through some points. until I get to U. So ST. Yeah, look at that. And now U, V, W, X, Y, Z. Am I like so dumb that I U, V, W, what happened to X and Y? Oh, stupid. I guess that GeoGebra by default doesn't let you name a point X or Y, or at least doesn't do it by default. Oops. Okay, well that's a nice excuse for us to go over here to this calculator button, which allows us to like relabel things. Nah, man, you Z, really do want you to be called X, and this point A1, I really do want you to be called Y, and this last point, I really do want you to be called Z. Okay, that was kind of an advanced move, never mind. All right, anyway, now I want to make my edges, so I click on segment, and you just do the normal thing. You just go jump. Okay, so there's 100 ways in which this can go wrong, and even though GeoGebra is kind of, on one hand, it's an incredibly amazing piece of software, on the other hand, it's so annoying. And eventually, at least for me, after repeated use, I got good at it, but it took a while. Okay, so this is, I believe, a picture. This is the graph on the left, and the graph on the right is far simpler, and it's just this. Okay, so this entire problem just reduces to, are these graphs isomorphic or not? And okay, look, it's possible. How long did this take us? I don't know, 3-4 minutes? Maybe this wasn't a good use of time, because perhaps it's obvious to you that these graphs are isomorphic, or perhaps it's obvious to you that they're not. I actually don't even know the answer. By the way, anytime you want to drag things around, you gotta click on move. All right, I'm gonna end this video really fast. So, hey, I'm just making a really quick video, and then I'm gonna be done with work for the day. Yeah, woo! Okay, so what are we doing? We got these two graphs. Are these two graphs isomorphic? Well, let's go through the basic facts. They both are graphs with 6 vertices. Check. Do they both have the same number of edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 3, 4, 5, 6, 7, 8, 9. Yes. Do they both have the same degree sequence? In fact, these are all cubic graphs, which is to say all the vertices have degree 3. So maybe they are isomorphic. Well, maybe they're not. The simplest way to show that two graphs are isomorphic is to just take one graph and just like drag it and bend it around until it looks exactly like the other one. This is the easiest way for a human to do this. And if you're very, very smart and you have extreme powers of visualization, perhaps you can just do this whole thing in your head, or perhaps you can draw it on your paper like in stages, but this is just way, way easier. So in other words, can I, now that I've created these vertices and I've created the edges, the whole point of a interactive geometry software, dynamic geometry software is called, is that, this edge now is like defined to be the edge connecting vertex A and vertex D, of course. And so as I drag vertex D around, like the edge goes with it. So basically this whole problem is just, dude, can you just like drag this around and make this picture look like this picture? And, maybe I know what I'm doing, maybe I don't. But I guess the answer is yes. No, I just went in a big circle there. Maybe I need to do this. Well, this is going to be kind of embarrassing if I don't know what I'm doing. All right, so, whoa. Wait. I thought the answer was yes. But actually, now I'm not sure. Oh, wait a second. I thought that the answer was yes. But now, well, even if the answer is no, you can still help yourself by dragging it into a situation that's more obvious. Yeah, alright, duh, I changed my mind. These graphs are obviously not isomorphic in retrospect. Because, look at the graph on the right. The graph on the right has 2 cycles. Two cycles of length 3, 2 3 cycles. But this graph just does not have a 3 cycle. Look, start from any arbitrary vertex. And in fact, this graph has 4 cycles of length 4. whereas this graph only has like 2 or 3 cycles of length 4, I guess. This one, and the big one, whereas this one has 4 at least cycles of length 4. Okay, the point is that it didn't take me too long there to try to drag. It's more impressive when the answer is yes, they are isomorphic, because then you get this very satisfying thing where you turn the left picture into the right picture. But either way, now I'm because of my inability to do this, I'm now convinced that these graphs are non-isomorphic, which encouraged me then to look for a property that one of them has and the other one doesn't. This graph has a cycle of length 3. In fact, it has 2. This graph just does not have a cycle of length 3. I'm just confirming that by like a brute force check. So anyway, these graphs are not isomorphic. So I think that you should all use GeoGebra to do this homework assignment, and hopefully you don't have too much trouble with it. Okay, goodbye.